Okay, so I'm going to talk to you quickly about how moments work. Here's the equation. Moment equals force times perpendicular distance from the pivot. The force in newtons, the distance in meters, so we get a unit for moment of Newton meters, which could vary. If the distance was in centimeters, it would be Newton centimeters, but most of the time you'll see it as Newton meters. Moment is the turning force of something, so it's how easily it can turn something. So let's take a quick look at this diagram. I'll kind of minimize this and bring in this picture. This is a safety valve. If the force of the steam, the pressure of the steam gets too high, it releases some steam to lower the pressure. So we've got a couple of moments going on here. We've always got clockwise moments and anti-clockwise moments. So you've got to know which way is which. And here is the clockwise one produced by the force of the steam. To balance that, we've got the anti-clockwise one from a weight. So we've got to look at a few cases. We look at when the red one is bigger than the blue one, when the red one is equal to the blue one, and when the blue one is bigger than the red one. So let's look at the first case. The red one is the biggest. That means that the clockwise moment, that's this one, is bigger than the anti-clockwise moment. Therefore, the arm will turn upwards, and we will get steam released, which will lower the pressure. Let's look at when they're equal then. When they're equal, it'll stay exactly as it is. It's in equilibrium. When there's no net moment, it's in equilibrium. If the blue one is bigger than the red one, then that means that the weight is pulling down harder. It's providing a bigger turning force, so it's definitely going to stay closed. It's going to actually be pushed down against the steam. It's interesting to also note that the force provided by the weight only needs to be about half as much as the force provided by the steam. And that's because the moment is equal to the force times the distance. So the further away you are, and the weight is about twice as far away from the pivot as this bit is, that means you need half as much force to provide the same moment. And this is the reason why we use levers and crowbars to kind of, to turn a switch, or it's why a door is wide. If you try and push a door by the hinge, you'll struggle to open it because the moment is small, because the distance from your finger to the hinge is small. If you try and open a door, right by the handle, it's very, very easy. So this was figured out, hundreds of years ago, and we used it to mean we could move heavy things. You move a big heavy rock by putting a big steel bar underneath it and kind of pulling it down from the end of the steel bar. Hopefully that sums up moments for you, and you've got a rough idea of how they work now. Go away and have a look at some questions on this to make sure that you understand fully.